Equations of lines lesson. We yesterday did an example where you've got two ordered pairs, and then we take them and we make them into a slope-intercept equation. So we need to take a look at a word problem relating to that. So rather than having everybody spend a lot of time writing one, I want everyone to look on page 139, example 4, and it's got lacrosse players, and they are participating in a survey, it says. And the survey results increased from 300,000 in 2009 to 400,000 in 2013. So really what we have is we have a pair of ordered pairs in this. If you look on your page, on page 139, where 9 represents the year 2009 and 13 represents the year 2013. So it's just like this problem, except for there's 9 and 13 in your X places, and there's 300,000 and there's 400,000 in your Y places. So if you'll notice, the process on that problem in the example in your book is exactly the same. 400,000 minus 300,000 over 13 minus 9, which ended up giving you the slope of 25,000. So it was 25,000 players per year. When we have y equals mx plus b, the m, the slope, represents a rate of change. So in a word problem, you're looking for a rate of change in this. I know I don't have another new one up here, but since we've got it in our book, we can look at that. So 25,000 players per year would be our rate of change in that particular problem. And then when we plug in our 300,000 and our 9, as they used in the example, one of the ordered pairs, you could solve for B and get 75,000 by this same process that we did yesterday for the other problem, and then plug in at the end, and the equation they got, y equals 25,000 x plus 75,000, now has a context to it. 25,000 players per year times the number of years plus the 75,000 to start with ended up giving the right answer for that question. So putting it in context with a word problem, but the same process that I gave you as an extra example that wasn't in your book, because I think we needed both instead of just one. All right. So moving on from there, we need to start looking at, first of all, finding an equation of a line from a graph. And then if you have a point that's not on that graph, finding the equation of a line parallel and the equation of a line perpendicular. So our first thing, if we're trying to find the equation of a line, we start with slope-intercept form, which is what? So y equals mx plus b. What does m stand for? Slope. And what does b stand for? In a graph like this, what is our y-intercept? 1. So 1 is our y-intercept. So that means what letter equals 1? B. So b equals 1. And our slope we find by counting rise over run. So we're going maybe from this point to this point. So our rise is actually not a rise, it's a fall. So it's how many down? 2 down and 1 over. So our slope is -2 over 1 or -2. So pretty nice with a graph such as this, you can just write the equation from that. Y equals m slope -2 over 1, x plus 1 our y-intercept. So y equals m x plus b. Down 2, right 1 makes our slope. B is our y-intercept, and you just plug it in. So nice, easy way of making an equation from a very well-drawn graph. Now, where we're taking this and where the book wants us to go with this, because it's geometry, we need to think about parallel lines and perpendicular lines. We've also done that in Algebra 2. You also touch on that in Algebra 1, but once again, focusing in geometry because parallel and perpendicular are big important points. Now, what did we say about the slopes of parallel lines from the other section? Slopes of parallel lines are equal, are the same. So if I want to have an equation that goes through point P that has an equal slope, that slope of that line is also going to have to be down 2 over 1, down 2 over 1. So on this, a graph such as this, we could probably even just count it out, but we need to have the other method rather than just counting it out. So for our question, you need to write down, we're going to find the equation of the line parallel to K, that's a K, cursive K, that goes through P. And we're going to run through some math for that. So we'll jump right to the math page for that. The problem might be written like this. The equation of the line with slope -2 that goes through the point -1, -3. So the slope is -2. How do we know the slope was -2 from the other one? How do we know the slope of the new line is -2? Down 2 over 1, and the slope has to be what because it's parallel? Equal, the same, good. So it has to be -2 again in our slope. And our point's here. So we need to use that process you used yesterday of finding y equals mx plus b and plugging in order to solve. Josie, what goes in for y? And what goes in for m? And what goes in for b? I mean, not b, x. -1. And then solve for b. Go ahead and plug it in. I'm going to reveal it here a little bit at a time, but I would prefer that you look down and solve the problem in front of you rather than looking up and being a scribe. It's just better for you. You should look up to check to make sure you're on the right track, but the more of the thinking you're doing rather than just copying, the better it is for you. What I love is I'm seeing a lot of people right now following that advice and actually doing the problem. So for those of you that are not in the room right now, hope you're having a good time. Negative times negative makes positive. Don't forget that, and then don't forget when you take away from both sides, you've got a negative plus negative, which gives you another negative. You've got -5 for equaling to b. So y equals mx plus b, put it back, and what does the answer look like then? Okay, great job, Nando. He said y equals -2x minus 5. Exactly. They can hear your voices they can hear my voice way better than your voice. So yes, just heard that. Now, we're going to add a question to that. We're going to add a question to that. So we just found the line parallel. What's different when we're doing a perpendicular line? Negative reciprocal. So we're going to do that and find our negative reciprocal in a minute after we take a look at the graph of the line. So the graph of the line through this down 2 over 1, down 2 over 1. Very nice that it does go through ordered pair 0, -5, the y-intercept 1, 2, 3, 4, 5, then down 2 over 1, or up to left 1 also works for that. And then our final question for this particular lesson, find the equation of the line perpendicular to K through P. Find the equation of the line perpendicular to K through P. So as I said, we need to think about perpendicular rules. So our slope is the negative reciprocal. So what does that make the slope? The new slope. If this is the old slope, -2, be 1/2, good. Because -2 over 1 flips over to 1/2 and turns positive. So I want you to take a minute and I want you to work through finding the equation of a line where the slope is 1/2 because it's the negative reciprocal of -2 over 1. And it goes through same point, -1, 3. So as you went through, you plugged in your numbers, y equals mx plus b, -3 times 1/2 times -1 plus b. Then when you multiply that out and then you add it to both sides, none of you got fooled, good job. We get -2.5 or -2.5 for b. And your equation y equals 1/2 x minus 2.5, or minus 2.5 is fine also, or minus 5/2. It's just when you think graphing, it's a little bit harder to think 5/2 where that belongs on the number line. So we plug in, we work carefully, we get our answer. We have this one. Then if you want to graph it, we'd start at -2.5, which would be here. And then where do you go from that? Up 1, right 2. So you do end up being in those halfway points. You're half here, up 1 over 2, up 1 over 2, up 1 over 2, in those little halves. Okay, so here we go up 1 over 2, up 1 over 2, up 1 over 2. And the only reason I drew it in is because it's really good to have a visual to know that when you actually did the problem and you did all the work, that this really is perpendicular. This kind of fits with that other theorem that we had also, that if you have a line that's parallel to another line and it's perpendicular to one line, it also has to be perpendicular to the other line. So if we have this line, we have one that's perpendicular to that one, it also has to be perpendicular to the other one. So it's good how it all kind of works out. The algebra side of it connects with the geometry side of it. They all work together. And so that's the whole point, is that math works regardless of what setting you're in. If you can't change what the math answer is going to be just because you change to a different class. Just because you're using it in science rather than in math, it's still the same math. It just sometimes looks a little bit different, but not significantly. All right. Everybody say hi, Iris. Hi. All right. We miss you. Have fun. All right, let's